So thank you very much. I'm pretty excited to see all of you here. I think we are right on a time, so we'll start right on a time. So we can go out right on a time. The topic is pretty simple. Run, query, run, a fresh look at a SQL weight stats. I hope you guys can hear me well, right? Yeah, good. All right. Yeah, because I sometimes cannot understand how far the voice is going, is good or not, but I'm glad it's working fine. And you guys can see me as well? I'm already zoomed out. All right, the good then. Okay, let's get started. A lot of things to talk about it in this 1 hour. And those who have attended my workshop before, I think some part of this will be repeated for you. So please stay with me, have a patience. But something is definitely new for everybody. So what is the weight statistics? Let's talk about weight statistics. But before weight statistics we talk about, I want to talk about one thing with you guys. Have you guys ever faced a situation that when you are running your queries, everything is running perfectly fine, and suddenly things get slower, and then by the time your boss reports, by the time you figure it out, and you just once again try those same queries, they start running fine. And now you don't know what went wrong. Has it ever happened to you? Yes? All right. I can see you guys now because my eyes are trained with this big tube of the lights. So yeah, you can raise hand, nod, everything is fine. So welcome. And welcome to all of you guys who are also watching online. I see plenty of you are also watching online, so that's good number. So thank you. So yeah, with that, I want to start about talking about it. Have you ever thought what could be the one reason why your server is sometime behaving certain ways? It works fine, but then suddenly gets slower. What is the one pain point of your server which is actually preventing your queries to run faster? How do we figure it out? What is that one thing if you can do to your server and your server will run faster? How do we figure it out? What's its pain? Right? Sometimes we are feeling tired, we are not able to walk, but when we go to doctor, they will tell you that we have a fever maybe, and that's why we have another side effect. We sometimes, as a developer or as a DBA, get lost into these side effects. We try to fix those side effects, but we sometimes do not go and figure it out root cause of our troubles. So that's our session is today about. So weight statistics. What is weight statistics? So if I talk about, for any query, there are three status, three situations, or three places the query can be. Either it's running. If it is running, we are happy. That's what we want. But sometimes queries are runnable. Anybody know what is runnable is? Yeah, please attempt. The query which is ready to run, and it has everything what it needs, but still one or two things is missing. It's ready to run, but something is missing. And the third one is suspended. Do you know what is suspended means? It is missing a lot of things. Lot of different resources it is missing, and it wants those resources. So if you provide those resources, it will say, I will be runnable and I will start running. And then it will start running once it has everything. Yeah, so that's what the query statistics, and these are the three status are. So if I have to simply say it, this is how it will look. So query arrives, first is runnable. When it's runnable, it's waiting for CPU. Once it has CPU, it will say, I'll start running. But then sometime it's running, it misses things out. Like, oh, table which I need to read data, it's locked. I have a CPU, but I need a table. Table is locked. Okay. Or sometime hard drive is so busy. I have a CPU, I have a table, my hard drive I'm missing. Sometime it doesn't have a memory, or sometimes something locked here and there. Then it goes back to suspended state, and when the resources are available, we'll start running and eventually get complete. I want to take a simplest example to explain you a coffee shop. Let's think about a coffee shop. How does it work? When we go to take a coffee, sometimes what happens? Sometimes there is a huge line to just park our car so we can get down and take a coffee. Sometimes we go and there is a big line inside. Sometimes there is a line at register where they are just taking our order. Sometimes the barista makes us wait. Sometimes coffee is with us, but it's too hot. We just have to wait. All these are waits. Exactly similar thing happens with query as well. Query also have a different kind of weights, and that is what we need to understand. Once you figure it out, what is making your queries to wait most of the time? And if you address that, your root cause or most of your biggest problems will be resolved. And you would be so happy, like, oh, I wish I knew this thing. I would have not spent time on other things. So there are 3 things which we are going to discuss today. One of them is CX packet wait, where entire team is not working together. I'll talk more in terms of demonstration. Second thing, we'll talk about asynchronous network I/O, where your application, because this is developer conference, I was been told, said, sometime happens where application, the query runs slower, but then when you run in a SSMS, query runs faster. It works on my PC, just not in application. Has it ever happened to you? Happens to me all the time. And I think that's why my people hire me. Said it works on a SQL Server Management Studio, doesn't work in application. Maybe this guy is the problem. But we never pay attention. Is it the problem with you? We'll figure that one out. Or sometime, write log is an issue. If that is the issue, well, we will figure it out, everything about it. And this is the URL where you can just drop your email and get the couple of scripts. So if you want to take a screenshot, you can take it. But it's just sqlauthority.com. You can just go there and get it, and you will get the email back. And I'll share with you very, very soon. With this, we are done with our slides. Now, I think the real fun begins. Yeah. Yeah, woohoo, that's good. I like it. At least one person is excited with demonstration. So before I start, this is going to be interactive. I know you guys are sitting all the way back. How would you interact with me? But I want to talk to you guys. So let's play a 1-minute game, and then we'll right away start with our main demonstration. Guys, ready? So I will ask you a random question. Do you guys see on a screen? Let's see how many of you get it right. It's a fun one. What happens if I run this? What do you guys think? What would be the answer? If I run this, what would be the answer? 1, 3. Wow, so silent. Guys, I need your participation. So that's how it is, because alone I can't do this. Look at this. All 3, when I run it, I'm going to get 1. Now my question to you is that, what will I get if I run this? Error? How many think it's error? Let's play the simple way. Error, how many? Just raise the hand, it's fun. Just for a minute. Then we are directly jumping into more complex stuff. Okay, all of you think error. Good. 1. One person says 1, but rest of them are error. Oh, it's 1. Good. Oh, no. It was no error. It was perfectly valid operation. What about this? Okay, one person is stuck on one number, but I think it's invalid. 1. How many think it's invalid? Oh, see, all of you smart folks. Yes. So I think you guys are all in a, I need to know what level I need to present, right? So this is helping me, and we are becoming more and more friends. Yeah? Good job, good job. No, this is perfectly fine. Now what about this? This is easy one. This is something we all learn in our kindergarten. Simplest thing ever. When we don't have anything, and if somebody takes away everything from nothing, what do you have? Oh, you didn't get it. It was hard. You have nothing, and somebody takes everything from nothing. What are you left with? Exactly. Let's see what is the answer of that. 1. Do you know why? It is very simple. And I think I got it now. I understood this is going to be great session now. I think mine and your level matches. See, it was very easy. I don't know why you didn't get it. So look at this. 4 divided by 4 will be the answer. 1, right? So 3 divided by 3, what will be the answer? 1. 0 divided by 0, 1. And we have already looked at count 1 is 1. I already gave you hint. Anyway, I think I need to start a little bit more complex now. So I think I understood. I have more things, but I think I'll stop here. So we already discussed about the query, how the query runs, and query status is, and everything. And we already talked about 3 things, status of the query. I will share this script with you guys, so that's why I'm just showing you, so you guys can remember this. There are various wait statistics, Every query, when it runs, it faces various problems. Sometimes it's good, sometimes it's bad, and that is what we are going to here learn about it. So there is a very, very simple script which is available in SQL Server. When you particularly run this one, it will tell you exactly what is running in your system and who is blocking your system most of the time. Where can you get a script? I already showed you URL. If you still don't know, I'll once again show you. Or you can just send me email or search on the internet. Thousands of experts has written this script. How to find weight statistics for your server. Use anybody's thing. Everybody's right. It's your interpretation is that question. Otherwise, scripts are all correct, right? Just like that one by one kind of thing. So here, when you run this particular query, this, if you want to learn more, this is the URL where you can go and learn. If you want your own, if you want to write an email, this is my email address. These are the weight statistics which tells you what exactly your server is waiting when the queries has to run. So that is that simple. So now, some are good, some are bad. Something which is good, I have already filtered it out in a where condition. But things which is bad will surface over here. And this data we are collecting since last server restart. So if you have restarted your server, this will reset. OK? So that's it. And now let's start running this. But before you run it, if you want, you can also clear it. Means you can reset this if you run this particular script. I hope the guy on the last can see this, right? You guys can see the script? Yeah, because a couple of presentations I set through, and I understand the problem if you are all the way to the back. I can also increase it a little bit. All right, fine. Now I'm sure. Now if you can't still read it, I think you need to check, go to eye doctors. Yeah? So I clear this one. These are the weight statistics. Let's start with the first problem which I want to discuss about. In a SQL Server, we have two kind of files. One is data file, and second one is log file, right? Those are the two files. I hope you guys are familiar with it. What is the best practices says for both the files placement on a disk? Like if you go and read on internet, what does it say? Separate them. Very, very correct. That's what I keep on hearing about it. And it's such an incomplete advice. I don't know who wrote this one, but the person really just wrote half the statement and left it, and we just are comfortably reading that half statement. That's not true. There is way more to that. Definitely it has to be separate. So yeah, half-truth is there, but the other half-truth actually hurts us more. And that's what we are going to do. See that right now. All right? So I want to, instead of asking question, I want to demonstrate it, identify the problem, and solve it with you. So we are going to create 3 different situations. First, not this one, sorry. Yeah, here it is. First, I am going to put both these drives together, the data and log together. Now, the E drive on my system is not fast enough. I know that. That's what I'm telling you. It's not fast enough. Second situation, I am going to put my data on a fastest possible drive which is there on my system. It's super fast, super fast. And in a third case, I'm going to put my data on a slow, but my log on a fast. Now, in this situation, out of 3, which one will win? That is what we have to figure it out. And how do we know which is the winner, which drive is faster, if you have done the right thing or not? Or let's learn this thing. Like if you let's assume that you are a performance tuning consultant. You have been hired, or your boss tells you, hey, we have to go and figure it out why things are running slow. Is our placement correct or not? Let's see. So first thing first, what I'm going to do is I'm going to create the database where everything is on a slow drive. And it has to be there. The reason is that, I'm always so nervous before presentation. I try my demo so many times, sometimes I forget to just reset them. Are you guys ever nervous when you do presentation or go and your boss calls you for performance review? Or your boss gets nervous? I mean, he's coming there and I have to do his performance review, something like that. Okay, so I just created that, created a table. Now, I'm clearing the weight statistics, and then after, I will be inserting some rows for 30 seconds. So this is going to run for 30 seconds, all right? And then after, I will count how many rows I have inserted. So those who didn't understand, what I'm going to do is that I created a database, and now I'm going to insert some rows here for 30 seconds and will count how many rows I have inserted. That's it. This is going to run for 30 seconds. After that, I will go and measure the write log or weight statistics. It will tell me something. It should tell me something. Because right now, my data and log are together. So let's wait for 30 seconds. It's already 15 seconds done. OK, 10 more to go. 5. All right, it's about to be done. Good. All right, it finished in 30 seconds, and it has inserted this many rows. OK, I know the number. I kept it in mind. Now let's go and check the weight statistics. So this will tell me what is going on. OK, so this is the number which I got it after I ran it. And you can clearly see the number 1 here is write log. Do you guys see that? Write log. My server has a problem of write log, and this is the reason it is not running faster. Sometimes, when inserts are not running, we just spend time saying, maybe the indexes are there. We need to drop the indexes. How many columns are we inserting? How much data we have? Actually, we should check the weight statistics first and see what exactly is going on under the hood. Here it tells me write log is an issue. This is what the reason my queries are slow. And do you know how much delay this particular write log has introduced? 14 seconds. Out of 30 seconds, 14 seconds, my query has not done anything. It was just sitting there, like, nothing. It was just there, sleeping. And after that, it decided to run. Yeah, you guys think this is a joke, right? I know this is a heavy subject. This is like extra advanced subject. I don't know why I wrote it down and I end up with a single SQL session here, but I'm glad you guys are here. At least you guys go home and tell your boss that look at write log, and it is 44% in a total time. 15 seconds, my query didn't do anything. This is the problem. Fine. Let me write it down. Now we will do the second experiment. OK, second one coming up. This time I'm smart, so I'll try to drop it. OK. I'm just creating it. This time, data is on a faster drive. Please note, guys. So this time, insert should go faster. I created a table. Now, I'll clear the weight statistics. Once again, run for 30 seconds. See, please understand, previously, both of them were on a slow drive. Now, my data is on an amazingly fast drive, super fast drive. So in 30 seconds, you'll definitely see some improvement, great improvement. And that's exactly what we are. You know, where should we put our data? Do you guys read more data or do you guys write more data? Read? How many of you are saying read more? Oh, yeah, we all read more only. That's what it is, database is for. Insert once, read more. Oh, way more result, right? Look at the first time what we got. Result, yeah, it is here. So I'll move it here. How many rows? This much rows. And this time, I got way more row than that. You know what? I'm going to write in a same file. So it's easier to compare when we want to compare, and we don't have to switch things. And what about our weight statistics? Are you guys ready to see? Let's see. Oh, so weight statistic did reduce, but not much. You can see that, right? And it went up by 54%, but the time here is 12 seconds. OK. Well, one thing I learned when I was a kid, My physics teacher was very kind to me when I was in 11th and 12th standard. He always said, whatever results you get, whatever observation you have, you write it down. So I write it down. And he says, even though it's wrong, you write it down. So I write it down. Guess what happens? When I go to check my copy with him, he always deducts my marks. Why? He said, your results are wrong. I said, you told me not to modify in anything, and now you're deducting it. So sometimes truth is costly, exactly like that. Yeah? So I didn't understand him. For entire year, I wrote the right numbers because he told me to do right numbers. When I went to him, he said, your results are wrong. I said, you never teach me what is the right thing to do. So now, let's go to third demo. So this time, once again, I will drop it. Now my question to all of you, my friend, is, look at, this is even a worse situation. This is where I want you are me and I'm your physics teacher. Look at E and D drive. My data is on a slow drive. My data is on slow drive. But log is on fast. Will it help? How much will it help? Then how much will it help? Please understand, my data is still slow. So please understand the most important thing. If we write from data, then we have to write log. And if we write in a log first, then we have to write in data. We have to move eventually our data to MDF file or log file. Where do you read our data from? MDF or log? MDF. Data file, right? Ultimately, things are going to be in data file. And if that is in a slow drive, that's a problem. And the problem is here. So now we will see if it goes bad or if it gets better. I'm creating the table. Now after creating table, we'll be running this. Please be ready for the revelation, right? 30 seconds. After 30 seconds, we'll know if it is improved or not improved. What do you guys think? How many of you think it will be improved? Okay. How many think it will be de-improved or not improved? Only a couple of them. Maybe you guys are right. We don't know. We'll know soon. So, 6 more seconds for the truth to be revealed. Whoa. So, this is a huge number, isn't it? Compared to previous times? Okay, now looking at this, what do you guys think will be the right log? How much will be the right log? More or less? Less? How many for less? How many for more? You guys have just, let's see. Oh, 11 seconds. No, this is not it. One problem we definitely solved, which is the right log. Look at this. Do you guys see that? Do you guys see this? This is nothing. We really got it to almost nothing. Right? This was a problem for us, nothing else. But we always spend time somewhere else. Just like how my physics teacher has taught me. We always look for the truth, but sometimes the problem is hidden somewhere else. But do you know what happened by doing this? We fixed one thing, but now we have a different problem. Do you guys know what problem we are right now having? I'll show you. It's going to be fun. But I hope you guys understand how weight statistics actually points us to the real problem, not the side effects. And it's one of the most effective way to do performance tuning. So, with that, let's go back and check our weight statistics. Look at this. Right log is nothing, but at the same time, we have a 3-page I/O latch there. And combination of them is around 11, 14, and 3, 17. So 17 seconds of problem we have introduced. This query can be even faster now, I can tell you this. Do you know what is page IO let stands for? Page. Page, what is page means? You are in a database, if you hear the page, that would be page from either I/O or from the memory. Latch is internal locking. Oh, so whoever is, I was about to fall off. Anyway, I was just worried about the guy who is behind me, not me. I mean, nothing happens to me. Look at me, I always survived. So, yeah. Sometimes it happens like, you know, I always have a trouble. The guy who is next to me is always worried. Anyway, page I/O latch. Page and I/O latch, it is related to memory and buffer. So data, which is from your memory to buffer when it is moved, or from page, which is memory, to I/O, which is moved, this is what it is. If you fix even this, your number will be even bigger. You can practically go all the way and double this number as well, if you can just fix it. There is a way to fix this one, but I am not going to cover that today, because I want to cover more demonstration and more concepts. But are you guys with me so far? Have you understand how you can use the weight statistics to understand the real trouble? Okay, now I have another question for you. CPU. More CPU is good or less? Less? Then we should not have a 2 cores, 4 cores, 6 core. Why are you looking for a phone which is like a dual core and Snapdragon and Snapdragon and a lot of things we look for sometime when we are buying phones? So here is the question again. Do you want your server to have a more CPU, a 4 core, 8 core, 16 core? What do you would like to have? More, right? I mean, it's a common sense. I haven't asked tricky question yet. I think you guys are just so far confused that I always ask tricky question. No, simple question. We want more CPU for our server. Yes. Yes. Yeah. Why is less? I mean, we want more. But we want less CPU for our query. Yes or no? We want powerful multi-core server for our multi-core CPU for our server, but we want very little CPU or thread for our query. Agreed? Yes? Okay, yes. Okay, because you said yes loudly, I will prove it. Yeah, let's see. This is going to be super interesting demonstration. So let's see a very, very simple query. Do you guys see this query particularly which is on the screen right now? Right now, do you see this query with the double arrows here? Double arrows? What does that mean actually? That means this particular operator is running in a parallel. It is processing multiple rows in parallel. How do we prove it? Yeah, I learned the trick. First, let the yellow thing come up, pop up, and then after right-click on it, then you can see. So here is the properties of that particular operator. Do you see right now that 20 threads are processing my data? Do you see that? So that's a good thing actually. Because you know what, think about this way, I have a 20 CPU on my machine, and 20 CPUs are being processed by my, all the rows are being distributed and they are being processed. This is a good thing. Very, very good thing. Now my question to all of you folks is, there is a keyword which is max degree of parallelism. If I give it 10, well, let's run it for 20 first. Let me write it down number. So what I'm going to do is that instead of 25, I'm going to run it for 20 times. And we will just measure the time, and we'll write it down over here. All right? So Let me clear the weight statistics first. I cleared the weight statistics. I'll run this, and we'll measure the time. Sorry about that. It might have hurt somebody's ear, I'm sure, who is sitting next to the speaker. So what I've done, I have a query which is running on a 20 cores. That's it. And I'm just running it, certain amount of the, something fell off from my mic. It's okay. Even my voice was so loud, it fell off. Anyway. Oh, it took 20 seconds. Do you guys see that? It took 20 seconds. So it ran this query 20 times in a 20 seconds. Great. Easy to remember. And now I'll go and check my weight statistics right now. Let's see what weight statistics I get. Oh, CX packet weight 291. Okay, 291. Let me write it down. I think this is going to be another interesting demonstration, okay? So what is CX packet weight? Well, write log was time it is taking to writing in a log easier. CX packet weight means, well, to explain I need half an hour, but we don't have it. So I'm going to explain you in the simplest possible way. Wastage in your CPU. How about that? Just extremely simple way understand this. That means, think about this way. I had a 20 CPU threads running, 20, and I ran it for 20 minutes. So what is the total CPU consumption? 400 seconds. 20 CPU threads ran for 20 seconds, 20 into 20, 400. Out of that, 291 was wastage. That means my CPU was only good for 109 seconds. That's it. Why it is wastage and everything, I'll be happy to talk to you. I'm here for another day. Or you can write an email, or we can discuss also, no worries. If I have time, I will discuss more about it. But for the moment, for a demonstration purpose, understand that 291 seconds is wastage. Now my question to you is this. What happens if I give half of the CPU than before to my query? Will it run faster or slower? Previously, I gave a 20, right? Now I am going to give it only 10. And this is the command which will tell me to run it in a 10. So previously, I had 2 queries, 20 CPU threads. Now I have half of it. Think of that as a like big pile of the work you have to do. Previously, you had a 20 helper. Now you have half of the employees to do that. Will it take more or less? What is common sense says? Less, right? Yeah, let's see that. So now, technically, I have half the resources. That means this query should take double the time. So I believe this query will run for 40 seconds. And I know you guys are very patient, so let's wait. After 40 seconds, we'll figure it out. It's already 11 seconds done. 1/4 we are done. Now about to be 20 seconds. Look at that. And it's done in 20 seconds. What? I gave half of the CPU than before, and still took 20 seconds. You can see that here. Wow, then I think the 20 extra guy I had was good for nothing. Rest of the 10 didn't do anything. You know, there is internet memes going on. There is a guy who is helping people to move stuff but never touches it. Okay, nobody's seen it except me. Yeah. And when you are doing presentation, your phone call has to ring. That's always the case. Okay, let's look at the CX packet weight here. And what was the number? 168. Okay, that is reduced. So my wastage is reduced. But what happens if I run this with 4? How about this? I'm going to run this with 4 and quickly do a test, and then we will come to a very quickly conclusion, and then we will see another demonstration. And I want to teach you something super important. This is the primary reason most of the time your server is running slow. Why it is running slow, we'll know very, very quickly. But right now, with the max degree of parallelism, that's a command which I'm giving you, and that is what telling my query to run only. That's telling my query to only run with a 4 of the CPU. So with a 4, it should take, what happened here? It finished. Yeah. Whoa. 18 seconds. Do you guys see that? Now, with the 4, I have 18 seconds. And what would be my wait statistics? Okay, 64. That means my wastage has further reduced. 64. Do you want me to try it with the 2 and 1 or not? I'll let you guys decide. Because, as you can see, as I reduce the number of the CPU to my query is running faster. Okay, we'll try one last. And then I will explain you what exactly is happening. And this may be the reason your system is also running slow and you guys have no idea. This is a query level hint where I'm telling my query to only use 2 CPU. Now, if you don't believe it, I'll go to execution plan and will show it to you. But what is happening right now is this. My query is right now distributing workload across the 2 of the CPU. And look at that. From 20, it took 22. Seems like 2 didn't work out for us. I can go and check the CX packet weight, but seems like 2 didn't work out for us. 4 was the right answer for my queries. Even though this has further reduced it, not really much of the performance. And if I put it 1, I know this would not be as efficient. But you know what? Now we are trying it. I think we should better try this one. So what I'm going to do is that I'm going to run this thing with a single CPU right now, no more parallelism. And after I run it, we will go and check the time. Guys, this is the #1 problem most of the server in the internet suffering. I've been doing performance tuning consultancy from 21 years, and I can tell you, this is the #1 reason for most of the server which I encounter are slow in the world. And this is what most of the people do not address it. Let me explain you why. So right now, it took 27 seconds. So this was also not a right thing. Our sweet spot was a 4. I know the CX packet won't be anything, but yeah, right now you won't see a CX packet weight, but this is not the right number. So it is very, very clear from this demonstration that 4 was the right number for my queries. You know what actually happened? When you are running with a 20, so when I run this with 4, previously it was distributed, the work was distributed among the 20 of my thread. Now, when it is distributed among 20 of the thread, SQL Server was not able to do the efficient work. But now, when I'm able to spread it across 3, the distribution is relatively even, and SQL Server is able to perform much, much, much better. There are many technical reasons. As I said, I don't want to go too much into technical reason. There is a NUMA node. There is a cost threshold of parallelism. There is a max degree of parallelism. Long story short, most of the time, your queries do not need all of your CPU. OK, another question, let me ask you this. Have you ever faced that your CPU never hits 100%, no matter what you do? Like your CPU never goes 100%. Your server is running slow, but your CPU is always 20 or 30%. Like, you don't know. That's one of the most common thing. If you have not seen it, go and check it. I'm sure it is happening right now. CPU will never hit. It will be 40%, 30%. But your server will definitely be slow. Then, if that is the case, this configuration is the primary reason. Ideally, your CPU should be running at 100%. Why you don't want to run it at 100%? Why don't you want it? You purchased it. Like, if you don't use your CPU, what are you going to do with that CPU? I mean, the CPU which went in the past, how good it is to you? What is it going to give you advantage? Satisfaction? To what? Our ego? Which is already hurt because our server is running slow. Why? I mean, it's like a lot of people come to me and said, our CPU is running 40%, but now it's running 60. And I said, oh, great. He said, what is great about it? I said, well, okay, sorry, it is not good. He said, yeah, that's what we are better here. I said, yeah, definitely you should be sorry. Still 40% to go. It's running 60. Should be running at near 100. Right? Maximize your resources. Have you ever heard about this thing? At least talk to your HR manager. He will tell you, he or she, that how the maximize resources is their priority. If you are 3 people, they're always looking for getting work done by 2. And if I show this demo to them, what will happen to you guys? I should do this for HR professionals. CX packet weight, max drop for HR professionals. Have less people, you get more work done because they are scared. Now start working every day. Instead of 7, they'll start working at 7 and will log in at 8 to prove they are efficient. I've done that once, got caught. Since then, I'm independent consultant. Yeah, sometimes you get work more and you get fired. You never know what is the actual policies are. I mean, so anyway, that was a joke. No, I was not fired. I was asked to resign. Immediate effect. But that's good actually, isn't it? I mean, who wants to come tomorrow if you are fired today? Yeah. Okay. So when my CPU was 20, my all 20 threads were busy. I'm simplifying this for you guys right now. Actually, there are way more number of threads than 20. But all the 20 threads were busy. But when you went to the 4, matter of the fact, you reduce your workload from 20 to 1/5. That means now you can run your workload 5 times more. You pretty much made your other threads available for other CPUs, other workloads, other queries. Previously, your other queries were waiting behind another one. Now, your queries will run. Here, one guy is getting addressed, but the rest of them are waiting behind it. Not good. Look at this is a classic scenario. I mean, this is what I made it. The classic scenario. And if you guys wonder how did I do it, definitely I used Gen AI tools. I will not tell you that I used ChatGPT for it. How do you know somebody used ChatGPT? Because there are a lot of spelling mistakes. Like evenly. Is this even spelling? No. So this is the case, like this is one CPU, okay? This is the second CPU, this is the third CPU. The guys who are in a green are the CPUs. And look at that, how they are behaving. They are all trying to treat to the one customer where your other customers are waiting. No, if these are 4 guys and there are 4 customers, each of them should have served to their own customer, isn't it? That's the right way to do it. But they don't do it sometimes. Do you want 4 chefs to make a single dessert? No. You want all the 4 chefs to make different food so your clients can be addressed. Similarly, you don't want all your threads to just addressing one query. You, matter of the fact, want parallel queries. And that is why don't let your query to consume all the threads. Not only it will run slow, it will make sure you parallelly not let other queries to run slower. Are you clear with this much so far? Yes. Good. At least somebody said yes. And how do you control it? There are 2 ways to control it. I will just show you that very, very quickly. And we have still 12 minutes, so we'll do something fun. Don't worry, I have one more demo. So you can go to database properties. Click on advanced. I'm zooming in a second. Don't worry. And here is the max degree of parallelism. It is set to 0. That means everything. In Microsoft, most of the time, 0 means everything. And 100 means everything. Not kidding. Search on the internet, fill factor 0 means what? And the answer you will find it, fill factor 0 means fill factor 100. And what is fill factor 100 means? 0. Yeah. No, not funny. It's truth. Certain truths are more funnier than lies or fake stories. So similarly, max degree of parallelism is set to 0. It's not a good idea. I can also change it over here 4. And that means my all the database on this server will now use 4 threads. But I can also change the cost threshold of parallelism, but this is a big story. Maybe if you guys want, next time when I will come back, I'll tell you a story about cost threshold of parallelism, because the story is even bigger. But to give you a point to read, like let's assume that you come for consultancy to me. So you said, okay, Pinal, we are hiring you. Tell us what is the right number. Well, I don't know the right number, okay? I don't know the right number. Those people who are taking photograph, first of all, write it down to your email first, and then take photograph. Nobody knows what is the right number here. But everybody knows what is the wrong number. That is what we need to remember. If you search on the internet, what should be the cost threshold of parallelism? Somebody will say, it should be 30. Somebody will say, it should be 50. Somebody said 25. But everybody saying, it should not be 5. So everybody agrees what should not be. Zero, my heart skipped actually, and I become speechless. The reason is that when you set it to 0, pretty much every query will always go parallelism. Yeah. And that means maybe it's a similar scenario, right? Either you want to leave the organization or organization already left you. In those scenarios, you set that to 0. And everything in a parallel world, and everybody will be flying. Superman here and there. Next day, server will be out. So, but if you ask me, this would be my starting point. Now you guys don't have to hire me or any other expert. I am giving you starting point. This is what I would usually set to my server. Conditionally, there are more than 4 CPU, okay? If you have 2 CPU, set it to 4 is equivalent to 0. Conditionally, you have more than 4. Now, how about this? I tell you this. For max degree of parallelism, Microsoft has given official documentation. So you follow that. There is search on the internet for max degree of parallelism, and you will find Microsoft has given an official documentation on this one. So you should follow that one. But for the cost threshold of parallelism, there is not an official documentation. So there are so many unofficial people like me. Half of the time we have no idea. Like we just think we know every single server in the world and blindly will give you advice. Set it to 30. That's a good starting point. Do you know why? How we protect ourselves? We are saying this is a starting point. We are not saying this is the right value. But once you start, what you will look for? That should be your question. Okay, I started this. Like, you know, when you're asking direction, said, yeah, you start your car and then call me. Okay, I started my car. Now what? What should I look for? Where should I go? Left, right, straight? No, look at your weight statistics again. Make sure your CX packet weight is not more than 40%. If it is still 90%, you have still more adjustment to do. All right? That should be your end result. Now, you will ask me, where does the 40 number came from? Same way, I don't know that's 30. The same origin is for that 40. An entire internet will tell you, CX packet weight should be 40%, 30%, 35%, 39%, 42%. Nobody knows what is right number. But everybody knows it should be less than 50. So, there we go. Are you taking your selfie with your big camera? No? Oh, okay. That's good. Yeah, it's interesting. I mean, no, he was looking with him. So I thought, okay, you come here to take my photo, your photo. I mean, but that's your prerogative. You are the good photographer, you decide. Yeah, if I should look cool, okay? Photoshop, you know Photoshop? Okay. Yeah, or you should have told me I can, anyway. Guys, are we clear with this max degree of parallelism? Yes, good. Okay, you are standing here for a while. How about I ask him question? Okay, so let me ask one question to our photographer. And then, don't leave. Stay. Where are you going? Okay, tell me, sir. Oh, no, I'll give you easy problem. Yeah. Tell me what will be the answer of this? Null? Wow, this guy seems like he knows his stuff. Look at that. Look at one. How about this? Because you said null, I will ask you about this one. What will be the answer of this then? Double null. Okay, he says double null. What about others? Thank you for participating. Yeah, thank you again. What about others? 1? How many for 1? I love your spirit. Some people just like to be wrong. Null, when it's not a valid. But what about 1 plus null? Come on. Those we thought 1, those who thought it's incorrect, those who thought error, I think you guys have not worked with SQL Server long enough. You guys think these are fun questions? No, not fun question. I've seen people getting incorrect results. When they are dividing one column value to another column value, they have a null values, 0 values, 1 values, and they come up with the wrong answer for years and years. This was actually figured out from one of the financial company who actually hired me, because they figured it out after 20 years. They were in a minus by $3 million. This was happening. One column had a null. When it divides, 0. They were losing money. Truth. As I said, I can't make up stories like this. How do I figure it out? Do you think I have enough time in my life I go 1 divided by null and then count? Nobody does those kind of things, man. I'm a busy person. I have many of this. And I am going to ask you, what do you guys think will happen with this? Come on, last one before I show you the one last demo. How many for 1? How many for 0? How many for error? I'll do it after the session. Oh, no, I am not that bad person. So thank you, guys. Thank you. Yeah, all right. I mean, we don't, no, you guys clap at the end, right? Yeah, fine. I'll show you one final demo. How do I know? There are 2 things which I'm going to show you very, very quickly in next 8 minutes, okay? How do you, like if you send me, so if you ever reach out to me and say, I want to hire you, do you know what I will ask you? I'll say, send me your weight statistics. Because if I see weight statistics, I know what problem going on in your system. And then I can fix it, right? If I can't fix it, I will say, you know what? I think your server is running fine. You don't have to hire me. So from weight statistics, I can figure it out a lot of things. I can figure it out. You have a write log problem, your CPU problem, your memory problem, you have an indexing problem, you are over-indexed, you are under-indexed, no index, or you are just 1 divided by 0%. You know, a lot of things you can figure it out. So how do I know that you are over-indexed or under-indexed? I'll show you very, very quickly. So 2 demonstrations in next 5 minutes. I'm creating a table and creating few index on it. That's it. Yeah, and my wife somehow, I told her I'm busy right now, and she has to call me today right now only. Yeah. Okay, I'll send her a photograph so she will not disturb me. Yeah. Only to her. Yeah. Yes. This is the joke I tell every time. She never calls me. Actually, she uses this as an excuse. She will say, I thought you were in a conference, so I didn't call you for 3 days. I was like, what is that, actually? So look at that. I'm inserting my data. And while inserting my data, oh, I need to reset the weight statistics, which I forgot. No problem. I am resetting my weight statistics. I resetted my weight statistics, and I am inserting data. And then, oh, here I had a script. I am just counting the thing. This is a very interesting demo. There are 2 things which I'm going to show you. Those who have seen this demo in my workshop, there's still new stuff coming in this demo, so hold on. So really, I am inserting a data into the first table, first index table right now. While data is being inserted there, I'm trying to select this thing. Do you see the count star? Why this is not returning me any result, do you guys know? Because table is actually locked. Table is actually locked right now because I have indexes on it. How long it takes and all these puzzles I'm not here to play. But I'm just trying to show you that there is a table. Table is index, and index, because of index, when I'm running my query is facing a trouble right now. and this query is not getting complete. Now, those folks who are going to ask me, what happens if we use no lock? You have to wait till this one is over, okay? The no lock is next line. I'll run it after this. But look at this. It's running right now. So let's wait. It is really taking long. OK, it finished counting. It finished counting, OK? How long it took? 61 seconds. Let me go to my wait statistics. Do you see anywhere 61 second one task? Oh, wow. This is how I know you are over-indexed. So only thing I have to do, whatever you have done in the past, we just have to undo and your server will run faster. Wait statistics will tell you so many things, so easily, so precise, amazing tool, we just don't use it. I mean, that's the beauty actually, and I love it because people don't use it, people don't learn it. Better for me. This is how I run my family. Bread, earning bread. Are we clear? If you see this particular wait statistics, this one, LCK_M_IS, that means you are over-indexed, you need to evaluate your indexes. And for that, you need a missing index and unused index script. Where you can find it, I already showed you. If you have not seen it, I'll show you again one more time. Hold on. I have 2 more minutes. Do you want to see one more demo of no lock? Yeah? All right. Yeah. I like to start on time and I like to finish on time, just so you guys know. And this demo might take 2 minutes. So I'm once again making the insert. OK, insert started. And now this is a no lock. You know, a lot of people uses no lock. Anybody uses no lock in the system? OK, great people. I use it too. Look at this is right now the same number. But just wait a bit. Just wait a bit. And soon you will see, oh, it's increasing. Do you guys see this is increasing? Yes? Oh, now finally I see 200K. But my execution is still going on. Do you see that? Let me stop this. And do you see this 200K? Remember back there? This is what no-lock do to you. So if you are comfortable with data like this, with flip-flops, it's a great tool. You don't have to use random function or anything. It just works every time. Particularly if you're in a finance business, don't, or use it, whatever. I mean, I am not your boss. You do whatever you have to do. But please don't try any of this on a production, because already a lot of people are doing it. So wait statistics tells you a lot more things than you want to do. If you want the scripts, you want to reach out to me, you want to talk to me just for fun, or you want to have a coffee with me, I'm always ready. This is where you can drop your email address, and it will send you auto mailer. It's a newsletter. And it will also send you a couple of things. One of them is wait statistics script. Second thing, how old your statistics are. Remember I mentioned the missing index script. Remember I talked, like it will tell you which indexes are missing in your system. It's a good and bad, but just use that as a starting point. Yeah, and where you will go after driving, that you can reach out to me later on by replying that email. Okay? And also it will give you unused index. If you're over indexed, you can just drop some of the indexes. Again, don't do all this on production. Just do on your demo or dev machine and never deploy on production. Or do it, but don't blame me for yes and no. But I just want to say thank you very, very much for coming and listening. So many of you and a lot of people are also watching online. So I want to clap for you guys. So thank you very much. Thanks for coming in. Yeah, appreciate it. Truly appreciate it.